Hello, this week we will be talking about the numerical integration. You know that we have just finished the numerical differentiation part. It was included in your midterm. And we will start the integration. And again, we will be talking about different methods for the numerical integration. Left endpoint rules, right endpoint rules, or left sum, right sum also. Maybe you saw it in calculus. And also, what else? The midpoint rule, trapezoidal rule, and the Simpsons rule. So we will be covering 5 different methods to be able to find numerical results of this integral from a to b f of x dx. So how can we find an approximate value for this integral? And you know that for these methods, all depends on the meaning of integral. Just as in different derivatives. Here you go. You know that the integral means the area under the curve. Our f function is there from a to b. What is the area of this shaded region? This is what we are trying to find approximately. Okay? And the idea is we are dividing this region into smaller pieces and trying to find the area of these smaller pieces and sum them up to be able to find the whole region. So that's why we are writing this equality. So this integral is almost equal to the sum of smaller regions. So these smaller regions, in general, we are showing with rectangles, and you know that area of a rectangle is base times the height, right? Base times the height. So here delta xi is gonna be the base length. So how much you will divide this area from A to B? It will give us the delta x length. And f of xi, since this is f of x, f of x will be the height of the rectangle. So base times height is gonna give us the area of this rectangle. So in here the difference of the methods are coming how you can choose this height. So the base is same. It will depend on how many pieces you divide from A to B. The base is like that. But for the height, you can divide these integrals or this area into different shapes. So once we are talking about integrals, we have 3 very straightforward choice to be able to find the height. And these are gonna come as left sum, right sum, and midpoint sum. Okay? So here the left sum is not that one. Actually, this is the left sum. I have to move this one there. So anyways, here you can see that the green areas, look at that, this green area for the first rectangle. So this is our base length. This A to B, if we call this one A to B, this is divided into 4 pieces. And the green rectangles are taking the height as right point. This is the right end point of the first rectangle. This is the second rectangle's right point. This is the third rectangle's right point, and this is the fourth one. As you can see, if you sum these green area, it will give us kind of the area under this shaded region. And you can see that this is going to be less than the real area. But if we take the left sum, this time look at these pink rectangles. For each rectangle, I am taking the right point as the height. Height times the base. Height times the base. This height, this time I am taking from the left parts of each rectangle. Or another way is we can take the midpoints. Look at these blue ones. Midpoint. If I take the midpoint now, I will get this, what is that? The purple region. And this is kind of the average of left and right. So the right sum is giving less than the real one. The left sum is giving more than the real value. And midpoint is giving kind of the average of these two. So you can imagine here that midpoint is going to give a better result for you. But I want you to know all of these methods, the ideas of these methods. Okay? I hope this is clear. I am passing out. Here you go. The same thing. The left end points you can see here. Each rectangle, we are taking the height from the left one. For the first one, the base is x1 minus a, the height is f of a. For the second one, f of x1, for the third, f of x2, for the fourth, f of x3. But if we are taking the right point, you can see that the first rectangle, we are taking f of x1, not f of a for the height. And for the middle ones, we are taking x1 plus a over 2. And similarly, for each midpoint, we have to find and we have to take the f of x of these points. Okay? These are the difference between three methods. And here you go. This is how we find. For xi, we are finding xi minus 1 plus xi over 2. And this xi bar is exactly that one times the base. And we are summing them up. This is the midpoint rule. And you can think this as b minus a over n. B and A is the starting point, B is the last point, N is how many p's you divide this area, equals times sum of f of xi bar. Xi bar is the midpoints of each region. Okay, this is how we can find the midpoint rule. Here this example was for the function minus x squared plus 5. I want you to try this function. Please try and find these sums, these sums results. Left sum, right sum, and midpoint sum. The actual area you can find it by taking the integral of this one from 0 to 2. Okay, and take this integral and find the actual area. And then use the left sum, right sum, and midpoint sum and find these results. And you need to send it to me until the Sunday, so that I can understand you are really watching these videos or not. And these are again some examples to compare these three methods. Here you go. We have an integral 16 minus x squared from 0 to 2 using n equals 4 rectangles and left hand points. First, we are starting with left hand points. We are dividing the region into 4 rectangles. That's why b minus a over n is going to be 2 minus 0 over 4, which is 1 over 2, which is 0.5. So left 1, left 2, left 3. So these are color coded. You can see that. 0.5 times x0. So I need to take the left point of each rectangle. 0.5 times f 0.5. So I will use the left hand points, which means that 0, 0.5, 1, and 1.5 to be able to find this area. Okay, and what you need to do is just plug in 0 for f, plug in 0.5, plug in 1, plug in 1.5, plug in this, and sum them up. You will see that the area will be 30.25. And what happens when we use right hand points? This time, instead of 0, 1, 1 over 2, 1, and 3 over 2, we will use the right ones, which means that we are going to start with 1 over 2, 1, 3 over 2, and 2. Again, the base areas are same, 0.5, but this time we need to sum them, the f 0.5 till f2. And if you plugged in this is what you will get. So you can see that this result is less than the real area. This result is more than the real area. And let's apply midpoint rule this time. So instead of 0, 1 over 2, 1, 3 over 2, and 2, we need to find the midpoints. So 1 over 2 plus 0 over 2, 1 over 4, 1 plus 1 over 2 over 2, 3 over 4. So you need to find these midpoints. And what is that? The base lengths are same. We are dividing into 4 pieces, but just the height part, we are taking the middle points. You just need to plug in 0.25, 0.75, 1.25, and 1.75. These are going to give the areas of each rectangle. These color coded. Make sure you understand that part. And you will get 29.375. You can see the error and the accuracy of these three methods. You can see that the midpoint rule gives us the accuracy 99.86%. So which is a good accuracy for numerical solutions.